Microsanj is a 15-year-old startup company that started in Silicon Valley. Our focus has been to get what I call technology that relates to measurement of fast and thermal. So it's a very unique kind of application that we developed. The technique was developed in university. I got the student. My job is to make money. So if you want to make money, come and see us. I go through some couple of slides because I don't want to bore you by that, but one of the things fundamental is thermo-reflectance. The idea and concept of thermo-reflectance is easy, has been around for 50 years, many people, and the whole idea is if you get a light, the light hit a surface, the reflected light depends on the temperature. You know, it's a simple concept, and has been for 50 years like this. And it takes always PhD students. It's a great project for them because you can spend many times to build it. And our goal was to make it commercial. Because up to technology like thermoreflectance, you use emission, and emission microscopy is very limited in terms of new devices and technologies. So it is a locking mechanism of leveraging light, signal processing, and build on that technology. So we commercialize this product. The best way I look at it is, for those of you, you can get a video view of a thermal in a device. And you can start by looking at a large board and going inside the actual transistor and see what is happening inside. So most of our customers are people who are doing the modeling and the measurement for high-speed devices. I already told jokingly that gallium nitride is my favorite product to put 3 kids through college. So I need just one more kid I have, so I need to just get one more device. I think it's because it's a very interesting challenge of temperature. Another thing is, anytime you take a device, you package it. And one of the things with packaging is, and as you saw in the presentation in here, I have to say you're in the golden age of packaging. Because up to the last few years, the king was the semiconductor people. They took the money, they developed this, 7 nanometer, 3 nanometer, like this, but that's the end of it. Because the physics has limited them. What is really now happening is packaging. And how do you really connect multi-technology in a fast way? And one of the key elements is using technologies like what we have developed to characterize these kind of devices. I think in that way, I see a lot of innovation next 5-10 years going on in this happening. When you do a time domain response, you can use a thermal camera and you can understand what is happening inside, correct? So this allows you to go to each interface of a package and look inside interposer. We can look at TSVs, we can look at the whole packaging, because end of the day, what is very important is the end device. You can have the most beautiful transistor, but if you cannot get the right performance, the end result will not work. There's a lot of applications. I put this for those of you who are interested. You're welcome to see me and I will share with you. This is an example of an EST device. The whole thing is like a video. You can actually see a thermal performance of your device as you turn it on. So from that perspective, over the last few years, what we have done is we look at multi-layer devices. How do you go inside the device, look inside. Look at another area that we have expanded the last 3 years is optical pump probe. And the reason for that is TSVs. This new packaging technique, interposers, how do you really characterize it is very important. And there's a lot of measurement data for that. And then another thing which is very important is commercial integration. For example, how many of you studied RF microwave in this group? Okay, you have a big problem because you need to learn that. Just studying mechanical will not take you very far. It's because what is happening? Antennas are getting integrated, packaging has all the electronics, and then what needs to do is you need to understand the interaction of these core technologies. The domain that used to be very different are getting integrated. And I do recommend, if you are really interested in that, look at that. Another thing that we have done recently is we have developed a way to measure electromagnetic waves. If you look at electromagnetic waves, TE waves, I'm sure you have studied in school, there's a great models, but nobody can see them. We can see it with our camera. So we have developed with chemistry, a transducer can convert electromagnetic energy to heat. And then we can look at our thermal camera and we can actually see things. For example, if your phone gets hot, you look at the actual antenna, you can see how the performance of the antenna is. So it's very interesting new technology. I hope that excites you to come and visit us in our booth. If you have a good question, we can always give you a present or jobs.